Hello guys, let's talk about acids and bases. We interact with these substances every day. Acids actually taste sour and they have a pH of less than 7. We are going to talk about the pH scale in more detail later. Bases taste bitter and they have a pH larger than 7. And then pH equals to 7 is neutral and water is actually neutral. Now, acids actually produce a piercing pain in a wound, but bases feel slippery. Examples of acid contain vinegar, lemon, orange juice, wine, banana, coffee, Diet Coke, all those things. Bases are baking soda, soap, antacid tablets, and different cleaning supplies. In chemistry, we define acids and bases with three different definitions. All these concepts are named after different scientists. The first one is Arrhenius's concept, where he said that when an acid dissolves in water, it's going to increase the concentration of the H plus ions. So let's take a look at an example. Let's take, for example, HCl, right? We know that HCl is a gas. When we dissolve it in water, it's going to produce H plus aqueous ions plus Cl minus also aqueous ions, so chloride ions. Now, this way we are going to increase the concentration of H plus in water. What's actually interesting is that H plus can combine with water, H2O liquid, and produce the so-called hydronium ion, H3O plus aqueous ion. So this is the so-called hydronium ion. And we can represent these two reactions combined in one reaction. So you can take HCl gas plus H2O liquid and produce Cl minus, or the chloride ion, plus the hydronium ion H3O plus, also aqueous. And what are bases? Bases are going to be substances that increase the concentration of the hydroxide ions in water. An example of this can be sodium hydroxide, NaOH. We know that this is a solid, and when we dissolve it in water, we are going to get Na plus aqueous ions and OH minus, or hydroxide ions. Okay, I hope this makes sense. Now, this concept is quite limited because we are talking only about aqueous solutions. So later, Brønsted and Lowry came up with a new concept, which is based on a transfer of the H plus ions, or transfer of protons in an acid-base reaction. So they said that an acid is going to be a proton donor, so a substance that gives away an H plus, and the base is going to be a substance that is going to accept that proton, so a proton acceptor. So let's look at an example. Let's do HCl again. And now I'm going to use the Lewis structures, plus let's react it with ammonia, NH3, right? And then what we are going to have here is the movement of H plus. So this hydrogen will get attached to ammonia. Because HCl is giving away the proton, that is going to be our acid. And because ammonia is accepting it, that is going to be our base. So on the other side, we are going to form the chloride ion, Cl minus, plus the ammonium ion, which is NH4. And we need to use these large brackets to show that this is positively charged. Now, an acid in this case is going to produce a so-called conjugate base. So this is a conjugate acid-base pair, and they literally differ only by an H plus ion. So the acid contains the H plus ion, the base does not contain it. Similarly, our ammonia is going to produce a conjugate acid. conjugate acid, which contains the H plus ion, and the base does not contain it. Okay, so an acid is going to produce a conjugate base, and the base is going to produce a conjugate acid in an acid-base reaction. Now, it's important to realize that all Arrhenius acids and bases are also BrnstedLowry acids and bases, but not all BrnstedLowry acids and bases are Arrhenius acids and bases, because the Arrhenius concept is limited to only aqueous solutions. Now, can we actually come up with a more generalized concept? Yes, we can. So actually, Lewis defined acids and bases based on electron pairs. So an acid is going to be an electron pair acceptor, and the base is going to be an electron pair donor. So let's have an example. For example, ammonia, so NH3, and we know that this has an electron pair right there, right? So this electron pair can be donated. So this is our base that donates the electron pair to, for example, boron trifluoride, BF3. So this electron pair will be donated there, and then on the other side as a product, we are going to form this compound right here. So BF3 accepted the electron pair, so that is going to be our acid. So any compound that can donate an electron pair is going to be a base, and any compound that can accept that electron pair is going to be an acid. Okay, I hope this makes sense. See you in the next video.